In this video, we're going to work through a couple of SLR parsing examples. So let's do a very simple example. Let's consider the grammar S goes to SA or S goes to B. And what does this grammar do? It produces strings of A's followed by a B. So any number of A's followed by a single B. And notice that the grammar is left recursive, and recall that that's not a problem for a bottom-up parser. SLR parsers, LR parsers are perfectly happy with left recursive grammars. So let's begin by working out what the automaton for this grammar should be, what the parsing automaton should be. And recall that the first step is to add a new production to the grammar. We have to add a new start symbol that all it does has one production that goes to the old start symbol. And that's, again, just for technical reasons. Now, the start symbol, or sorry, the start state of the NFA of the parsing automaton is this item. S prime, our new start symbol, goes to .s, our old start symbol. And rather than build the NFA and then do the subset of states construction, let's just go ahead and work out what items must be in the first state of the DFA. So remember that all the epsilon moves in the NFA are due to moves that happen because we don't see a non-terminal on the stack, but instead see something derived from that non-terminal. So if we have a dot right next to a non-terminal, that means that there's an epsilon move in the NFA to all the items that have, for all the productions, all the first items for the productions of that non-terminal. What do I mean by that? I mean that this state, it would be an epsilon production to S goes to dot SA, so this is the first item in recognizing this production, so the dot's all the way at the left, and there would also be an item for the other production for S goes to dot B. All right, so that's the epsilon closure in the NFA of this start item, so this would be the first state. These three things, these three items would be the first state of the DFA. And now we have to consider what would happen on each of the possible transitions for each of the symbols that we might see on the stack. So let's think about what happens if we see a B. So if we see a B on the stack, then the only item that's going to be in that state is S goes to B dot. Okay, so it would be fine to see a B, and this would be the only item that was valid for that stack contents. Now another possibility is that we'll see an S. Okay, so if we see an S on the stack, what will happen? Well, we're going to go to a state that has two items. S prime goes to S dot, so that we've seen S on the stack, and we're ready to reduce by this production, possibly. And also S goes to S dot A. And now, clearly in this state, so actually let's talk about this state down here. The state here at the bottom, there are no more transitions possible. There's only one item in the state, and the dot's all the way at the right-hand side, so that state is completely done. In this state, the one over here on the right side, well, one of these items is complete, the dot's all the way at the right, but the other item still has an A, and so there could be one more transition out of this state to the item S goes to SA dot. All right? And now if we look at this, we see that for the most part, these states are in pretty good shape. So these two states, this one down here and this one over here, they only have a single item. And so there's no possibility of a shift-reduce conflict in those states. There's only one item, there's only one thing to do. The only possibility here in both of these states is to reduce. This state, the initial start state, has no reduce moves. So there's only shift moves here. So there can't be a shift-reduce conflict because there are no reduce items, no possible reduce actions, and there's no reduce-reduce conflicts for the same reason. So the only state of interest, really, from the point of view of whether the grammar is SLR1, is this middle state. Okay, and here we could either reduce by S prime goes to S dot, or we could shift an A onto the stack. And the question is, what is in the follow of S prime? So what can follow S prime in the grammar? And if we look back up at our grammar, we'll see that nothing can follow S prime. S prime is the start symbol, and so in fact the only thing in the follow of S prime is the end of the input. And so what that tells us is that we'll reduce by S prime goes to S if we're out of input, and otherwise if there is an A on the stack, if there's an A in the input, then we'll shift it onto the stack. And so this grammar is SLR1. There are no shift reduce or reduce reduce conflicts implied by this parsing automaton. Let's do another example, slightly more complex. In fact, let's just extend the previous grammar. We'll have a production. S goes to SAS. Okay, so now we have the non-terminal twice with an A in between. Or S can go to B, just like before. And now let's work out the parsing automaton for this grammar. And once again, we'll need to add a dummy start symbol to the grammar. And it will go, its only production will be to generate the old start symbol. And now let's begin working out what's in the parsing automaton for this particular grammar. And just like before, we're not going to go through the effort of constructing the NFA. That would be a systematic way to do it. One way to do it is the way we sketch, which is just to construct the NFA first and then do the subset of states construction. But this grammar is small enough and simple enough that we can work out directly what is in, what are in the states, what items are in the states of the DFA. So just like before, because the dot here is immediately next to the S, we know that we can, without consuming any input at all, make an epsilon transition in the NFA to the items that start the productions for S. So these will be in this, also in the DFA state. And that's it. We can't add any other productions here. So S is the only non-terminal, and we've added all the first items, initial items for S, and so that is the complete state. Okay? So just like before, one possibility is that we'll see a B on the stack, and so that would give us the item S goes to B dot, and that's the only item valid for that state. Another possibility is that we'll see an S on the stack, okay, in which case we'll make a transition to the state S prime goes to S dot, and S goes to S dot AS. All right, so we saw that same state before in the other automaton. Now we could also see an A. And what state would that take us to? And this is going to be a little different. In this state, we could have the item, or we will have the item SA.S, but now notice that the dot is right next to S. So instead of seeing an S on the stack, we could also see something derived from S in the next position on the stack. And so we have to throw in all the productions for S. There's only 2 of them, but that means we could have the item S goes to dot SAS and S goes to dot B. All right, and then out of this state, now there are a couple of different possible transitions. We could see an S, or we could see a B. Well, if we see a B, then we wind up in this state over here. And if we see an S, well, what's going to happen? If we see an S, then we'll wind up in another new state. Where we have S goes to SAS dot. We've seen the complete right-hand side of that production. Or S goes to SA dot S. Actually, that dot's in the wrong place. So let's erase that. And let's put it in the right place. It's right here. Before the A, not after the A. All right? And now we have to think about what happens in this state. So in this state, the only possible input is an A. And if it's an A, what's going to happen? Well, we're going to have S goes to SA.S, and then we're going to have to add the initial productions for S again. And so that would just take us back to this state. And let me get the transitions labeled here. We go to this state on an S, and we come back to that state, the bottom state here, from the top state on an A. And I think, if we haven't made any mistakes, that is the complete transition system and all the states for this DFA. And now the question is this parsing automaton, is this the parsing automaton of a SLR1 grammar? And in order to answer that question, we have to look for possible reduce-reduce and shift-reduce conflicts. Well, a quick scan of all the states here will show you or convince you that there are not any states where there are two possible reduce moves. So there can't be any reduce-reduce conflicts in this automaton. We can ignore states that only have a single item or states that have no possible reduce moves at all, because those are states in which there cannot be a shift-reduce conflict. And that means we can ignore these two states, the two states over here at the extreme left. So now we're left with these three states to think about. All right, so we look at this state last time. As before, the follow of S prime is just equal to the dollar sign. And so there's no shift-reduce conflict in this state because on input A, we can only shift. We can't reduce by S prime goes to S. All right, now we're down to looking at these two states. And let's just consider this bottom state first. All right, so what does this state say to do? Well, this state says that, well, first of all, observe that the only transitions out of this state are on B and S, and there are no reduce moves in this state at all, so there's no possibility of a shift-reduce conflict in this state either. That leaves us with just this state to think about. All right, so now this state does have a reduce move. The first item here is a reduction, and that says that we should reduce by S goes to SAS if whatever comes next is in the follow of S. So we're going to need to know what is in the follow of S. Well, from S prime goes to S, we know that anything in the follow of S prime is in the follow of S. So clearly dollar is in the follow of S. And then from this part of the grammar here, we can see that A is in the follow of S. And then from this occurrence here of S, we know that since it occurs at the far right-hand side of the production, that anything in the follow of the right-hand side, the left-hand side non-terminal, is also going to be in the follow of S. Well, in this case, they're the same. It just says that the follow of S is a subset of the follow of S, which is trivially always true, and so it doesn't add anything new. And so we wind up with just the follow of S being these two things, dollar sign and A. But that poses a problem, because this says that if we see an A in the input, we should reduce. And this move here says that if we see an A in the input, we should shift. And so this state does have a shift-reduce conflict. All right, and so this grammar is not SLR1.